Next question. Consider the Boolean operator hash with the following properties. He has given 4 properties like this. Here he has not specified what is that Boolean operator, but regarding that Boolean operator he has given the 4 properties. Okay, in terms of x, one variable he has considered as x, another variable here 0, 1, here x, here x. Sorry, this is x bar. Last one is x bar. X hash x bar equal to 1. After writing these 4 properties, write down the question. Then x hash y is equivalent to. See here, let us consider 2 variables. One is x, another one is y. Okay. Since we are having 2 variables, we will be having 4 combinations of zeros and ones. Now let us write the corresponding output based on the given 4 statements. First statement is what? First operand is x, second operand is 0, right? Second operand is 0. That means here second operand is 0, 2 combinations we are having, right? If the second operand is 0, what is the output? X. Whatever the x value we are having, that will come as the output. Here x value is 0, that will come as the output. Here x value is 1, that will come as the output. Okay, next. Regarding this, we have done. Next one is, first operand is x, second operand is 1. Okay, second operand 1, we are having 2 cases. Here y is 1, here also y is 1. Next, what is the output? X bar, complement of x. That means here 0 is there, complement of it is 1. Here 1 I am having, complement of it is 0. X hash 1 equal to x bar. Is it clear up to now? Okay, now let us observe other 2 properties, whether it is satisfying or not. Okay, from the first 2, we have written the 4 combinations, what is the output. Okay, now let us cross check whether these 2 are also valid or not. Here, first variable and second variable both are same, output is 0. That means what? X equal to y equal to 0 or x equal to y equal to 1. That time output is 0. That means this is correct. Next, x hash x bar. That means here if you are considering 0, here it will be 1, or if it is 1, this will be 0. For those 2 combinations, here output is 1. 0 1 or 1 0, output is 1. Right? So that means all the 4 properties are satisfying. What is this truth table? Yeah, exclusive OR. 0 1 1 0, exclusive OR. X exclusive OR y. Okay. So actually here he is asking x hash y. So we got x exclusive OR y. So that means x hash y is nothing but x exclusive OR y. So this one we can write it as x bar y plus x y bar. He has given one of the options like this, x bar y plus x y bar. Next question. The binary operator hash is defined by the following truth table. Okay, after writing this one, write down the question. Which of the following is true about the binary operator hash? Write down the 4 choices. Option A, both commutative and associative. Option B, commutative but not associative. Option C, not commutative but associative. Option D, neither commutative nor associative. He has defined the Boolean operator like this. Just by looking at the truth table, we will come to know this is the exclusive OR, right? So let us check whether it is commutative and associative or not. Let us see. See, for this particular question, you can solve in 2 methods. One is by writing the expression, you can check whether it is valuing, whether it is obeying commutative and associative or not. Or since he has given the truth table, from that also we can check. See, commutative means, first let us see regarding commutative. See, if you are considering 2 variables x and y, among those 2 variables, if you are operating with the binary operator hash, you can change the order of the variables. If it is satisfying like it, that means that particular operator is satisfying commutative law, right? So from this particular truth table, we know this is the exclusive OR. So what we can write here, p hash q, we can write it as p bar q plus p q bar. So here first I am considering x hash y. In the place of p, substitute x. In the place of q, substitute y. Okay. First I am considering LHS x hash y. That equal to, here I will get x bar y plus x y bar. X bar y plus x y bar. Now I will consider RHS. That is y hash x. Y hash x. Okay. So here I will get y bar x plus y x bar. Substitute y in the place of p, x in the place of q. Y bar x plus y x bar. Okay. From here we can change the order of the variables because logical AND will satisfy commutative law. So here we can write x and y bar plus x bar and y. Okay. So this one and this one both are same. Right? So that means what? Exclusive OR operator will satisfy commutative law. Exclusive OR operator satisfies commutative law. Now let us see whether it is satisfying associative or not. Okay, with respect to function, you can do the same answer. Okay, since he has given the truth table, I will use the truth table approach in order to justify whether it is satisfying associative law or not. Okay, regarding associative law, here I am having three variables: x hash y hash z is same as x hash y hash z. See, if you are having three variables, you can perform that particular operation on any two variables first. Here I am performing on x and y first and then with z. Okay, here I am performing y and z first and then with x. If you are getting the same thing, then we can say this particular operator is satisfying associative law. Okay, I am considering first two variables x, y, 0, 0, 0, 1, 1, 0, 1, 1. Here in the place of p and q, consider x and y. Output will be 0, 1, 1, 0. Okay. Now I will consider z variable. You can consider anything. See, for the time being, I will consider 2 zeros here, 2 1s here. So that I will get all the four combinations here. You can assume any values. There is no issue. Here I am considering z value like this: 2 zeros, 2 1s. Here 0, 0, 0, 1, 1, 0, 1, 1. Okay. Now, here LHS term I am writing. LHS is what? X hash y hash z. That means whatever this column you are having, this column is like your P, this column is like Q. Okay. Here if you are having both values are different, that time only output is 1. If both values are same, output is 0. Right? Here both values are same, output is 0. What is the other combination? Here. Okay. For other two, these two values are different, so output is 1. Okay, next, I will consider y hash z first. That means, here I am having y variable, here z variable. Okay, consider this is like your p, this is like q. Okay, if both values are same, output is 0. If both values are different, output is 1. First let us write output is 0. Here both the values are 0, so output is 0. Both the values are 1, so output is 1. Output is 0. If both values are same, output is 0. Okay. Here 1, 0, output is 1, 0, 1, output is 1. Okay. Next, I am considering RHS term. What is RHS? X hash, y hash z. That means this x column and y hash z column. Okay. Here if both the values are same, output is 0. If both are different, output is 1. Right? So 0, 0 means output is 0. Here 1, here 1. Output is 0. Next, x value 0. Here value is 1, output is 1. Here x value is 1, here x value is 0, output is 1. Now observe LHS column and RHS column, whether those two are same or not. LHS column and RHS column, same, right? So that means exclusive OR operator satisfying associative law. Okay, in the previous class I have mentioned, when I am discussing about gray code, right? There I have mentioned exclusive OR operator will satisfy associative law. Okay. Now, here I am giving the proof how it is satisfying associative law. Okay, so that means answer for this question is option A. Whatever the binary operator hash, here that binary operator is nothing but exclusive OR. It is satisfying both commutative and associative. Okay, I am repeating once again regarding commutative law. See here, whatever the operator you are considering among two variables. Okay, if you are supposed to perform x hash y. Okay, if you are getting the same value, if you are just even though interchanging those variables y hash x, that means this particular binary operator will satisfy the commutative law. That means order of the variables you can interchange. If the order of the variables, even though we can interchange, whatever the resultant operation you are getting, okay, if it is same, then we can say this particular binary operator is satisfying commutative law. Okay, here first from this particular truth table, we got to know this is exclusive OR. So I have written P hash Q. That is nothing but P bar Q plus PQ bar. Okay. So here I am considering two variables x, y. Okay. X hash y equal to y hash x. Whether it is true or not, I am verifying. Okay. First I am considering LHS, that is x hash y. In the place of P, you are having x. In the place of Q, you are having y. Okay. Substitute here. You will get x bar y plus xy bar. Right. So this is regarding LHS. Now, RHS term I have considered. Here I am having y hash x. That means in the place of P, I am having y. In the place of Q, I am having x. Okay, substitute here y bar x plus y x bar. Okay, now logical and in the previous class we have mentioned logical and operator will satisfy commutative law, right? Y bar x is same as xy bar. Similarly, y x bar is same as x bar y. Okay, now xy bar, here you are having x bar y, here you are having. If you want, here logical or operator will satisfy commutative. That means you can write this x bar by here, xy bar here. Okay, so LHS and RHS both are same. That means exclusive OR operator satisfying commutative law. See, here I have taken Z column values of zeros and ones in such a way that in order to get all the four combinations, you can put the values of zeros and ones in any way. Okay. Here all the four combinations I will get, so I have considered 0 for two cases and 1 for two other cases, like that. You can assume Z column in any way, there is no issue. Because here what is happening in LHS term, whatever the Z values you are considering, okay, with that you are getting x hash y hash z. Okay, so with respect to same Z value only, here x hash y hash z, RHS term you are getting, right? So in that way you can choose the Z values. Okay, so now we understood exclusive OR operator satisfies both commutative law and associative law, right? So you can remember this particular property, especially the associative law. Exclusive OR operator satisfies associative law. Now with that property, let us solve one question. Okay, write down the question. Let x1 exclusive OR, x2 exclusive OR, x3 exclusive OR, x4 equal to 0, where x1, x2, x3 and x4 are the Boolean variables. Which of the following must always be true? Write down the four choices. Option A, logical AND, that is x1, x2, x3, x4 equal to 0. Option B, x1, x3 plus x2 equal to 0. Option C, x1 bar exclusive OR x3 bar equal to x2 bar exclusive OR x4 bar. Option D, logical OR, x1 plus x2 plus x3 plus x4 equal to 0. Here he has given this statement, exclusive OR operation among these four variables is 0. Okay, if this is 0, he has given four choices like this. Which of these one of these four choices will be always true? What is that? You have to find out. See, we can solve this particular question into three methods. Okay, first let us see. Here I am having four variables. Okay, among all those four variables, he has performed exclusive OR operation and he has mentioned output is 0. Okay, first let us understand regarding two variables, what is the output? Okay, we are already familiar regarding the truth table of exclusive OR among two variables, right? So first I am writing for two variables. This is the exclusive OR truth table, right? Y equal to A exclusive OR B, right? Just observe here input variables I am having two. Okay, that means we are having four combinations of zeros and ones, right? So if you observe at the output, for two combinations I am getting output as 0, for other two combinations I am getting output as 1, right? Here he is performing exclusive OR operation among four variables and the output is 0. Okay, here we are performing exclusive OR operation on two variables. We are getting output as 0 for two cases, first case and last case. Here I will put one more column just for our understanding. Number of ones. Here both the values are zeros, that means number of ones we don't have. that is 0. Okay, here I am having single 1, here also single 1. Number of ones is 1. Here I am having 2 ones. Just observe with respect to number of ones, that means at the input side, and look at the output when I am getting output is 0. If you are having number of ones is 0 or number of ones is 2, output is 0. Right? That means what? If you are having, see, 0 and 2 are nothing but what? Even numbers. Right? If you are having even number of ones at the input, output is 0. That is nothing but, that is for exclusive OR. If you are having odd number of ones, here odd number is 1. Okay. If you are having odd number of ones at the input, output is 1. Okay, you can make a note. Exclusive OR function will produce output as 0 for even number of ones at the input. Okay. Now, so this is the case for 2 variables. Now similarly for 4 variables. Here the 4 variables are x1, x2, x3, x4. Here I am having 4 variables. That means we can represent with 16 combinations of zeros and ones. But among 16 combinations, only 8 combinations will produce output as 1. Other 8 combinations will produce output as 0. Okay. Here we understood for even number of ones, output is 0. Right? So here I will consider only for those combinations, even number of ones. Okay. For those cases, output will be 0. Okay. So here whatever I am having, x1, xr, x2, xr, x3, xr, x4, that ended thing you can assume y. Here this ended thing I am assuming is y. Okay. So here I will get output as 0 for even number of ones. See, for 2 variables even number is 0 and 2. For 4 variables even number of ones will be 0, 2 and 4. 0, 2 and 4 for 4 variables. Number of ones is 0, number of ones is 2, number of ones is 4, like that. So first case is 4 zeros, output is 0. Next, 0001. 0001, you are having only single one, that is the odd number, so I won't consider. Next number is 0010. 0010 also you are having single one, that is the odd number, I won't consider. Next, 0011. Here number of ones is 2, right? So output is 0. Write in the ascending order first 4 combinations. Just try to find out the combinations where you are having number of ones is even. Here number of ones is 0, that is even number. Here number of ones is 2, it is an even number. For even number of ones, output is 0. Right? Next, 4 is not possible. 0100. Next, 5. 0101. Here number of ones is 2, output is 0. Next, 6. 0110. Okay. Write in the ascending order first 4 combinations. The moment here I got 4 combinations, with the help of these 4 I will write the remaining 4. See here, just complement it. This row just complement 1001. Here output is 0. Here number of ones is what? 2, even number. Similarly here 1010. Number of ones is 2, output is 0. 1100. Number of ones is 2, output is 0. Next, this one 4 ones. If you write in the ascending order first 4 combinations, from that just complement each case, you'll get 4 more combinations. Okay, that means what? Here if you are having 4 variables, total you will be having 16 combinations, among which these 8 combinations only will produce output as 0 when you are performing exclusive OR operation among those variables. Okay, so now I have considered the combinations for which here y equal to 0. Okay, now among the 4 choices, for all these combinations, whatever the relation he has given, that has to be true. Right? Now let us verify option A, whether it is true or not. Here logical and we are having output is 0. Here if you observe, output of this one will be 0 if we are having at least one of these variables as 0. Right? So from this combination to this combination, if you observe, you are having at least one of the input as 0. So you will get output as 0. Whereas for last case, all the variables are 1. If you substitute all the variables as 1, you will get output as 1. That means option A is not correct. Actually, for answering this question, this one particular case is sufficient. In order to eliminate, see, whenever you wanted to check which option is correct, if you don't know, you try to consider the combination of inputs in such a way that with the help of that particular combination of input, you can eliminate 3 options, okay, so that you can get the correct answer, like that. Okay, for answering this question, this one particular case is sufficient. See here, second option B is also wrong, because x1, x3 plus x2 is 0, right? So here, if you substitute 1 plus anything is 1, you are getting output as 1. Similarly, last case also. Okay, so obviously option C is correct. Now let us see whether option C is correct or not. Okay, here LHS term I am having x1 bar exclusive bar x3 bar. x1 bar exclusive bar x3 bar. Okay, see here we are having A XOR B. Simplify it, you will get A bar B plus AB bar. A bar B plus AB bar. Now you can substitute in the place of A x1 bar, in the place of B x3 bar. From here what we will get? Just substitute in the place of A x1 bar, in the place of B x3 bar. First term is A bar, that means x1 bar whole bar, and B is nothing but x3 bar. A B bar, A is x1 bar and B bar, that means x3 bar whole bar, x3 bar whole bar. So that means here you are getting x1 and x3 bar plus x1 bar and x3. That means what? AB bar plus A bar B is nothing but exclusive bar, A exclusive bar B. That means here I am getting x1 exclusive bar x3. Okay, so that means LHS term, whatever here he has given x1 bar XOR x3 bar, that is same as x1 exclusive bar x3. Similarly, x2 bar exclusive bar x4 bar is same as x2 exclusive bar x4, right? So here I am considering 2 more columns. One is LHS x1 exclusive bar x3. Similarly, RHS term I am considering it is x2 exclusive bar x4. x1 bar exclusive bar x3 bar I got it as x1 XOR x3. Similarly, this one will become x2 exclusive bar x4. Now just observe first column and third column and exclusive OR operation let us perform. Okay, here 0 0 output is 0, 0 1 output is 1, 1 0 0 output is 0, 0 1 output is 1, 1 0 1, 1 1 0, 1 0 1, 1 1 0. Okay, now x2 exclusive OR x4, second column and fourth column, 0 XOR 0 0, 0 XOR 1 1, 1 XOR 1 0, 1 XOR 0 1, 0 1 1, next 0 0 0, 1 0 1, 1 1 0. Just observe this column and this column, whether these two columns are same or not. These two columns are same. See here I have written this particular function with the help of this function. A XOR B is nothing but A bar B plus AB bar. In the place of A you are having x1 bar, in the place of B x3 bar. Substitute there. After doing simplification you will get x1 exclusive or x3. Okay, so that means whatever LHS term I am having I have written here. Similarly RHS term we can write like this. Now here I am having variables x1 x3, x1 x3. Just observe this column and this column. Okay, if both are same output is 0, if both are different output is 1. Like that you can form. Similarly x2 exclusive or x4. Here x2 column, x4 column. If both the values are same, output is 0. If both are different, output is 1. Like that. So we got this column and this column is same. That means what? LHS is same as RHS. That means option C is the correct. See, this is one particular method. For answering this question, this one particular combination is sufficient. That is the other method. Okay. Now, if you observe here, he has given this particular equation output is 0. Okay. In order to satisfy this one, among the 4 choices, one of the choice will be correct. Which one? That one. That is the question. Now, by looking at the given equation, here we are having exclusive OR operation. Okay. Just by looking at the 4 choices, here also we are having exclusive OR. So that means we can guess option C may be true. Right? So, I am doing reverse way. That means I will consider option C is the true, so that I should get whatever the statement he has given. That should be the true. Right? See, if this is true, what the among the given 4 choices, which one will be true? That is the forward direction. Now, by looking at here exclusive OR operation I am having, here if you observe the 4 choices, among 4 I am having only one choice is exclusive OR. Now I am doing the reverse. That means if I am assuming this is true, okay, then whatever the condition he has given, that has to be satisfied. Then this will be the correct answer, right? Otherwise this will be the wrong. Okay. Now I am assuming this is the true. Now I will prove whether I am getting this answer or not. See here, LHS is x1 bar exclusive OR x3 bar. That one I got it as x1 exclusive OR x3. Next, RHS, I am considering option C. That is x2 bar exclusive OR x4 bar. This is equal to x2 exclusive OR x4. Okay. Now I am considering option C is the true. Okay. So that I should get y value as 0. Right. Now I am considering this one. Y equal to x1 exclusive OR x2 exclusive OR x3 exclusive OR x4. Previously we got the conclusion exclusive OR operator is satisfying associative law, right? So we can perform exclusive OR operation on any two variables first, right? So I will rearrange this expression like this: x1 exclusive OR x3 exclusive OR x2 exclusive OR x4. When you are having 3 variables or more, okay, among all the variables, if you are performing the same operation, okay, if that particular operator is satisfying associative law, then you can perform that operation on any 2 variables first. Okay, now here I got x1 exclusive OR x3, here I got x2 exclusive OR x4. Okay, here I have considered option C is the true. That means what? Here x1 exclusive OR x3, that is LHS term. RHS term is x2 exclusive OR x4. Both are same, right? So that means you can assume this is like something P. So this is also will be P because both are same, right? This one is same as this one, right? So I am getting P exclusive OR P. What is the output? Just substitute here. See, first case and last case. If both are same, output is 0. So I am getting output is 0. I am getting 0. So that means option C is the correct. See, I am repeating once again. Just by from the given statement, you are having exclusive OR operation among the 4 variables. Just by looking at the 4 options, only one particular option is having XOR, right? So just I am guessing this will be the true. Okay, I am assuming option C is the true. That means whatever LHS term is there, RHS term, both are true. Okay, then whatever here he has given, that has to be true, right? So here I got x1 bar exclusive OR x3 bar is same as this one, right? Similarly, I can write this one as x2 exclusive OR x4. Okay, now I am considering this particular condition y. Y is x1 XOR x2 XOR x3 XOR x4. Okay, we have got one conclusion: exclusive OR operator satisfying associative law. That means you can perform XOR operation on any 2 variables first. So here what I am doing, x1 XOR x3 and then XOR with x2 exclusive OR x4. See here, x1 exclusive OR x3, here x2 exclusive OR x4, and then whatever XOR operator is there, that one here I put. Okay, these 2 are same. That means if this is 0, this will be 0, or if this is 1, this will be 1, like that. So here 0 XOR 0 or 1 XOR 1, like that 2 cases will come. If both the variables are 0, output is 0. If both the variables are 1, output is 0, right? So that means I am getting 0 as the answer. Next question, write down this expression. He has given f of pq like this. Okay, he is asking the simplified expression for f of pq. See here, as I mentioned earlier, exclusive OR operator will satisfy associative law, right? So here if you observe the entire expression, you are having only exclusive OR operation, right? So whatever may be the brackets he has given, you forget about it. You can rearrange whichever the order you want. Okay. So I am rearranging the order like this: 1 XOR P, exclusive OR P XOR Q, exclusive OR P XOR Q, and then exclusive OR Q XOR 0. Here entire equation or expression you are having only one operator, that is XOR. XOR will satisfy associative law. That means you can perform exclusive OR operation on any 2 variables first. Here what I have done, I have written this expression here, and then I am performing XOR on these two first. P XOR Q, XOR P XOR Q. See here, I am having P XOR Q, P XOR Q. Both are same. You can assume both are like X. If this is 0, this will be 0. Or if this is 1, this will be 1. Just look at this truth table. If both the values are zeros or both the values are 1, output is 0. Right? So that means this entire expression is 0. Okay. Exclusive OR. Here, one of the variable is Q, another variable is 0. Okay. For the time being, I am considering, say, A value is 0. See, Q XOR 0 is same as 0 exclusive OR Q. XOR will satisfy commutative law, right? So for the time being, I am considering A is 0. Now, observe the B input and the corresponding output. Here B value is 0, output is 0. Here B value is 1, output is 1. That means if A is 0, output will be other variable. Okay, that means here your B is nothing but here Q. A is nothing but 0. So output will be what? Q XOR 0 is what? See, first variable is 1, second variable is P. Okay, now here in the same truth table, you can consider A value is 1, 2 combinations you are having. I am considering A value is 1. Okay, now with respect to other variable, I will observe the output. If B value is 0, output is 1, that means complementing. If B value is 1, output is 0, right? So that means what? What I am getting? If A value is 1, output I am getting complement of B. That means here I have considered A is 1. Okay, other variable in the place of B, consider P. So here 1 XOR P is nothing but what? P bar, right? So you are getting P bar. Now, here we already got Q XOR 0 is same as 0 exclusive OR Q, that is same as Q. So that means P bar exclusive OR Q. Okay, now you can use this formula, substitute in the place of A P bar, in the place of B Q, what you are getting, just tell me. I am repeating once again. Okay, here exclusive OR operator will satisfy associative law, right? So you can perform XOR on any two variables first. So whatever the given expression, I have remodified like this: P XOR Q XOR P XOR Q, and then remaining like this. Okay, now here P XOR Q, P XOR Q, both are same. That means if this is 0, this will be 0, or if this is 1, this will be 1, like that, right? So here if both the variables are same, that means either both variables are 0 or both variables are 1, output is 0. So this entire thing we can write it as 0. Next, Q XOR 0 is same as 0 XOR Q. Okay, I have considered first variable is 0. First variable is 0. Now, I am looking at other variable and the output. Here if B is 0, output is 0, same. If B is 1, output is 1. That means I can write output is B, right? So here I will get Q, right? Here first variable is 1, second variable is P. Okay, I am looking at A value is 1, two cases. If B is 0, output is 1. That means complementing. If B is 1, output is 0, complementing, right? So that means if A value is 1, output is B bar. So here in the place of B, you are having P, so you are getting P bar. 0 XOR Q is same as Q XOR 0, that is Q, right? So P bar exclusive OR Q. What it is? PQ plus P bar Q bar, right? Exclusive NOR you are getting PQ plus P bar Q bar. Okay, so this one you can write it as complement of exclusive OR. One of the given choices he has given like this. So this is the correct answer. Or if you are having this is the answer in one of the choices, you can choose this one like that. XNOR. You will get XNOR among P and Q, that is same as complement of XOR. Next question, write down. The Boolean expression he has given like this. He is asking the simplified expression. So up to now we have solved the questions related to simplification of the Boolean functions, okay, with the help of basic rules and laws. From now we are discussing the questions related to complement. Yeah, answer is 0, correct. See, in EE you will get the more weightage for easy questions, dead easy questions. Okay. See here, if you observe inside the complement, you are having all the variables are logical or together, right? So that means here B bar plus B is 1. Okay. 1 plus anything is 1, right? Complement of 1 is nothing but 0. So answer is 0. See here, if you observe inside the complement, you are having all the variables are logical or together, right? So b plus b bar is 1, 1 plus anything is 1, logical or. 1 bar is 0. Answer is 0. See, for you are getting the answer as 0, but you will get the 2 marks. Answer is 0, 2 marks you will get for double E. Okay, now let us solve one more question related to ECE. You will get some answer, but that question is asked for 1 mark. The Boolean expression can be simplified too. See, this is the question asked for GATE ECE for 1 mark. You will get something as answer, okay, but you will get 1 mark only weightage. Whereas for double E, you are getting the answer as 0, but you will get 2 marks. That is the advantage of double E. You will get, for dead easy questions, you will get more weightage. What is the answer? X, right. See here, if you observe, you can take x bar as common. So here, you will get x bar into y bar plus 1. 1 plus anything is 1, okay. So here you are having overall complement. Now, here multiply x with these two, similarly y with these two. Okay, so x into x is x plus x into y bar plus x into y plus y into y bar is 0. Next, here I am taking x as common, 1 plus y bar plus y plus here this value is 1, right? X bar whole bar is nothing but x. So 1 plus anything is 1. So here you will get x plus x, that is nothing but x. So here after doing simplification you are getting something, right? X, but you will get 1 mark only for EC branch. Next question, which of the following is equivalent to the Boolean expression? You can write down y equal to AB plus BC plus CA. Write down the 4 choices. He has given the 4 choices like this. He has given the Boolean function, this one. This function is equivalent to which of the following? Yeah, option D is the correct, right? See here, just by looking at the 4 choices, you are having complement. Among the 4 choices, 3 choices are having complement. That means here we can write whatever the given function is there. If you are applying 2 times complement, you will get the same function. Okay. So here you can write, I am applying 2 times complement to the given function. That means AB plus BC plus CA. Whole bar, whole bar. Okay. Apply De Morgan's law here. You are having 3 terms summed together. So individual you will get complement. AB bar and BC bar and CA bar. And you are having overall complement. Okay. Now you apply once again De Morgan's law. You will get A bar plus B bar, B bar plus C bar, and C bar plus A bar. You are having overall complement. Y bar whole bar is nothing but Y. So that means option D is the correct. Okay. So here we have done 2 times complement. Okay. After that we have applied De Morgan's law. Okay. We got individual term complement. So once again we have applied De Morgan's law, right? So like this we have to continue the process if you are getting the complemented term, right? So one method is, whenever you are supposed to find the complement, you can use De Morgan's law, or I will give one more method. You can follow this method. You can write down, we can find the complement of a Boolean function f by following these steps. We can find the complement of Boolean function f by following these steps. First step is simplify the given Boolean function if possible. Okay. Second step, write the dual function. Okay. I am assuming that is, say, f suffix d. Given Boolean function is f. If simplification is possible, do it. If it is not possible, then write the dual. If simplification is possible, after doing simplification, write the dual function. Okay, I am assuming that is f suffix d. Next, complement each literal of above dual function. Okay, you can write down regarding literal. Literal is nothing but either the variable or its complement. See, if you are having 3 variables a, b, c. Okay, I am calling a, b, c as the variables. Okay, here literal means either the variable a or its complement, a bar. Okay, I will call it as literal. A bar, B bar, C bar. Okay, all those I will call it as literals. That is the meaning. Okay, now I am having the function AB plus BC plus CA. Suppose I am assuming AB plus BC plus CA. Okay, I wanted to find out the complement of this function. I want to find out the complement of this function. Okay, now what I will do, first I will write, see whether simplification is possible or not. Simplification not possible in this case. Okay, next write the dual function. Okay, apply dual to this one. I am assuming that is f suffix d. Okay, here you are having logical and, right? Wherever logical and is there, replace with logical and. What is the function you will get? Dual function. Yeah, a plus b and b plus c and c plus c, right? I will get the complement of the Boolean function, that is f bar, here by complementing each literal of above dual function. Literal means either the variable or its complement, right? So here I am having all the variables are like normal variables only. Okay, if you are having suppose a bar, there if you are applying once again complement means what? You will get a. Okay, so in this case I will get a bar plus b bar and b bar plus c bar and c bar plus a bar. See, first I will write the dual function and then I will complement each literal. Here all the literals are normal variables only. So here I got the complement. Okay, so this is same as what? Here I have considered AB plus BC plus CA as F. Okay, I have applied complement, so I am getting this inside this one, whatever you are having. A bar plus B bar plus C bar plus A bar. Okay, see whatever the De Morgan's law I have given, you can observe here with the help of these two steps. First one, suppose F equal to A and D. Okay, I wanted to perform the complement of this function, right? So first I will write the dual. FD is A plus B, and then I will get directly the complement of the given function just by complementing each literal. That means A bar plus B bar. AB whole bar is nothing but what? A bar plus B bar. Similarly, other De Morgan law is what? F equal to, I am assuming the function is A plus B. Okay, first I am writing the dual, that is A and D. Okay, now I will get directly the complement of the given function just by complementing each literal of above dual function, that is A bar and B bar. A plus B whole bar is nothing but A bar B bar. Okay, from the De Morgan law only I have given these two steps. Okay, so whichever method you feel comfortable you can use. Either you can apply De Morgan's law and you can do the simplification, or whatever the steps here I have given, you can follow this approach whenever you are supposed to find out the complement of any function.